All right, our notes are nice and quick today. We just have to discuss Z-scores. Remember, the information on the formula and such for Z-scores are also in your anchor chart for measures of position. So let's get started here. Who is taller, a man that is 73 inches tall or a woman who is 68 inches tall? Well, the man is taller, right? But aren't men taller than women on average? So who is taller relative to their gender, the 73-inch tall man or the 68-inch tall woman? There is a reason why we have standardizations. We want to be able to say, like, in retrospect. So me at 5'10" have been told that I'm tall my whole life, although the average male maybe is 5'10" themselves. So if I was a man, I would not receive that comment as often as I do. So the Z-score of an individual data tells us how many standard deviations. I'm going to zoom in so I can write that out. Told you this would be an important word, standard deviation. That value is from the population mean. So if X is our value, and this is going to be the population mean and population standard deviation, then the Z-score for X is going to be X minus mu, our mean, divided by our standard deviation. That's our little formula. Of course, we can also find Z-scores for our sample data, and that would just be X minus X bar over S. So we're just going to do 3 little practice problems together today, short and sweet. So here is the first one. So the National Center for Health Statistics study states that men's height, the mean height for adult men is 69.4. It'd be useful information, with a standard deviation of 3.1 inches. And then the mean height for women is 63.8 inches with a standard deviation of 2.8. So who is taller? The 73-inch tall man or the 68-inch tall woman? So we're going to do 2 separate problems here. Let's do yellow was a bad choice, so we'll do blue instead of yellow for our writing. We are going to say that our Z-score for our men is, or for our man, our X value, that's what comes first in our formula. He is 73 inches tall. Our average was 69.4. And we divide that by our standard deviation. Notice I'm underlining each of these values, and that's what's going to help me make sure that I use all of the information and all of the right information. When I put that in my calculator, and we'll round to 2 decimal places since it was given to us in 1, we get 1.16 for our Z-score. Now let's do the female. Z for our female is equal to her height, which is 68 inches, minus the average height, which is 63.8 inches. And then we're going to divide that by the women's standard deviation, which is 2.8. When I put that in my calculator, it comes out right to 1.5. So looking at this data, we can determine that the Z-score is bigger for the woman. So the woman is relatively taller because she has the biggest Z-score, which is just a fancy way of saying that she is further away from the mean. And the further away in the positive direction you get, the more significant that becomes. Let's try another one. See how that was really nice and comparative too. I really like that example. Eric proudly tells his brother Bruce that he got a 94 on his last math exam. So he got a 94, it have an average of 73 and a standard deviation of 9. And his brother's like, well, that's nice, but he got a 96 with an average of a 79 and a standard deviation of 7. So the boys want to compete and see, well, who really did better. So let's do Eric first. Eric is in green. His z-score, it's always your score, which is a 94, minus the average, which was a 73, divided by standard deviation. This one comes out to 2.33, so he did pretty good. Now let's look at Bruce. Z is equal to the score you got, which is a 96, minus the average, which was a 79. So his average was a little higher, but they had a standard deviation of 7. So let's see how this works itself out. So that's a 2.43. So who did relatively better? Bruce did. But not by a whole lot, by about 0.1 standard deviations. Ooh, now we're changing the problem. Suppose Eric's classmate got a z-score of negative 1.7. What was his exam score? So this is Eric's classmate. So we're going to use the green data here, and we're going to work backwards. If z equals your data minus the mean over the standard deviation, and we know our z-score, the standard deviation was still 9. The class average was still a 73. We just don't know x. So it's a little bit of algebra here. That's why you all had an Algebra 2 prerequisite. We're going to multiply both sides by 9. We get negative 15.3 is equal to x minus 73. I'm going to add 73 to both sides. And we're going to get x is equal to 57.7. So classmate did not do very well, which we could tell he didn't do well if he got a z-score of negative 1.7, definitely below average. Scored 57.7%. So just again here in this setup, we had to find x and work backwards, and that is definitely a skill that I would expect you guys to be able to do. So as you run through all of your z-score practice and such here, do keep in mind that you could be finding just a single z-score. You could be finding and comparing two z-scores, or like in example number 3, you could be working backwards to solve for x. But definitely write that formula down. It's one we'll use a lot this year.